Hello students, in the last session we saw the formation of depletion layer. In this session we will be continuing with the next topic, that is the barrier potential. So during the formation of depletion layer we saw that there is the positively charged ions on the N side and negatively charged ions on the P side. Because these charge carriers are immobile, that is they cannot move from their place like free electrons and holes. These charged ions, positively charged ions as well as the negatively charged ions, cannot move in the crystalline lattice structure, because of which they are going to establish an electric field across the junction. And this electric field produces a potential difference, what is known as the barrier potential or the junction barrier, which will be denoted by VB. We know that we are having two types of semiconductor, that is germanium as well as the silicon. In the germanium, the barrier potential, whatever it is being generated, it is 0.3 volts, whereas in case of silicon, it is 0.7 volts. In the P region and in the N region, because of the difference in the concentration gradient, we are going to see the electrons are crossing the junction from N region towards the P region, and the holes are crossing the junction from the P region to the N region. Likewise, we are going to see a region what is called as a depletion layer, where none of the charged particles will be present. And this depletion layer will be having the positively charged ions on the N side and the negatively charged ions on the P side, and this charged particles will establish an electric field, which in turn produces the potential difference, what is known as the potential barrier or the junction barrier. Now let us see what exactly is a junction diode. Junction diode is nothing but a device what is formed by combining one P region and one N region together. This junction itself, the junction which is formed when a P region and one N region, this is a P region and this is the N region, and the junction which is formed when we are going to combine the P layer and the N layer itself is called as a junction diode. And the symbolic representation of this junction diode is like this. There are two terminals in the diode. One is the anode, the other one is the cathode. The terminal which is connected towards the P layer will be called as anode, which will be denoted by A, and the terminal which is connected towards the N side is called as the cathode, and that will be denoted by the letter K. And the current will always flow from P layer to N layer or from anode to cathode. That is, the conventional current will always flow in this direction as shown in the diagram. This is the symbol of a diode, where this will be the P side, this will be the N side, and the terminal towards P side will be called as the anode, denoted by A, and the terminal towards the cathode is towards the N region is called as cathode, denoted by K. Now let us see what exactly is the meaning of biasing a PN junction. So biasing is nothing but connecting an external source to a junction diode or to a simple diode itself is called as biasing. That is, connecting an external source of certain EMF is called as biasing. We can bias the junction diode in two different ways. One is the forward bias, the other one is the reverse bias. Now let us see what exactly is the meaning of forward biasing of a diode. Whenever diode is nothing but a device which contains one P region and one N region. If P region is connected to positive terminal of the battery and N region is connected to negative terminal of the battery, then that type of biasing itself is called as forward biasing. If I am going to consider the symbol of a diode, this is a P side and this is the N side. P type is connected to positive terminal of the battery. The longer lead will be called as the positive terminal, the shorter lead will be called as negative terminal. So if P side is connected to positive terminal of the battery and N side is connected to negative terminal of the battery, then the diode is said to be forward biased. What happens when the diode is forward biased? Whenever the diode is forward biased, holes are majority in P region and electrons are majority in the N region. Whenever there is a junction or the diode is forward biased, holes in the P region are repelled from the positive terminal of the battery, and electrons from the N region are repelled due to the negative terminal of the battery. Because of this repulsion, we are going to see the electrons are moving towards the junction in the N region, and holes are moving towards the junction in the P region. And because of this movement, we are going to see that the width of the depletion region starts decreasing. At some point of a time, the depletion region will be completely eliminated and electrons can easily flow from N region to P region and through the source back to the N region. That is, current can easily flow in this direction. That is, the current will easily flow. That is, the electrons will easily flow in this direction. Since the electrons are flowing in this direction, we are going to see the conventional current is flowing in this direction. Conventional current direction is opposite to that of the electron flow. So, in the forward biasing condition, we are going to see the width of the depletion region decreases and the current increases with the increase in the external voltage. But one thing what we have to keep in mind is the external voltage whatever we are applying, that must be greater than Vp. The current will never flow until and unless the external voltage whatever we are applying, that is more than the barrier potential. And in the forward biasing condition, the junction offers low resistance, only because of which the current starts flowing in the junction. Now let us see what exactly is the meaning of reverse biasing condition. The diode is said to be reverse biased when the P region is connected to negative terminal of the battery and N region is connected to positive terminal of the battery. Whenever the diode is connected in this manner, the holes which are positively charged, they are majority in P region, they get attracted towards the negative terminal of the battery, because we know that unlike charges attract each other. Similarly, the electrons which are negatively charged, they are majority in number in N region and they get attracted towards the positive terminal of the battery, because of which the width of the depletion region increases. In depletion region ಅಂತ ಹೇಳಿದ್ರೆ a region where none of the charge carriers are present. Since these electrons as well as the holes are moving away from the junction, or these charge carriers are getting attracted towards the positive as well as the negative terminal of the battery, the width of the depletion region keeps on increasing, which in turn increases the barrier potential, which is denoted by Vp. And with the further increasing in this reverse biasing condition, there is further increase in the width of the depletion region, which in turn increases the barrier potential Vp. So in the reverse biasing condition, we can see that the current can never flow through the diode, and the resistance offered by this junction in the reverse biasing condition is very high. So the two important points what we have to remember in the reverse biasing condition is the P region is connected to negative terminal of the battery and N region is connected to positive terminal of the battery, and the width of the depletion region increases as well as resistance across the junction is high in the reverse biasing condition. These are the points what we are going to see under the reverse biasing of a diode. Now let us see what is called as the reverse saturation current. Till now we are just talking about the majority charge carriers which are present in the P region and the N region. But along with these majority charge carriers, there are some minority charge carriers also in the P region and the N region. In the P region, we are having electrons as the minority charge carriers, and in the N region, we are having holes as the minority charge carriers. The reverse biasing condition, whatever we are applying, that is P region is connected to negative terminal of the battery and N region is connected to positive terminal of the battery. And this reverse biasing condition will act like a forward biasing condition for the minority charge carriers which are present in the P region and N region. And we have also seen that during the forward biasing condition, the electrons will flow from N region to P region and through the outer circuit. So in the reverse biasing condition, the small amount of current will flow in the circuit, and that current is only because of the minority charge carriers, and this current is known as the leakage current, which is denoted by I naught, or it is also called as the reverse saturation current. And for silicon it is less than 1 microamp. For germanium it might exceed up to 10 microamps. Now let us see what exactly is the meaning of reverse breakdown. Just now we saw what is called as the leakage current, that is the current which is flowing through the diode due to minority charge carriers when the diode is reverse biased is called as leakage current. And this leakage current will increase the temperature of the device. And with the further increase in the reverse bias voltage across the junction, the reverse current through the junction also increases abruptly, and the point at which the reverse saturation current increases abruptly is called as the reverse breakdown, because at that point the diode will be broken down or the diode will be destroyed completely. So we have to make sure that if the reverse voltage applied is more than the VBR or the reverse breakdown voltage, then the diode will be permanently destroyed. Now let us see what is called as junction capacitance of a diode. Capacitor is nothing but two parallel plates where positive charges will be present on one plate and negative charges will be present on the other plate. The same kind of structure will be seen in the diode also near the junction. That is, whenever the diode is reverse biased, the existing depletion region exhibits the capacitance property due to immobile ions. Immobile ions in the sense positive ions that are present near the junction towards the N region and negative ions which are present near the junction uh, in the P region. They exhibit the capacitance property, and that itself will be called as the junction capacitance of a diode. So what is this transition capacitance or a space charge capacitance ಅಂತ ಹೇಳಿದ್ರೆ, I already told you that the width of the depletion region will increase with the increase in the reverse biasing voltage, and this capacitive effect, that is, in the capacitor also we have seen that with the increase in the external voltage the capacitance of a capacitor will increase, but here with the increase in the reverse bias voltage the width of the depletion region will increase, and this effect itself is called as the transition or the space charge capacitance, which will be denoted by CT. And the CT is related to the width of the depletion layer, that is W, by the relation CT is equal to epsilon A divided by W, where epsilon is nothing but the permittivity of the material. Which material we are using, accordingly the permittivity will also vary, and A is nothing but the surface area of the junction and W is nothing but the width of the depletion region. So let me conclude this session at this point. In my next session, we'll be dealing with the VI characteristics of a diode. Thank you.